Welcome to this comprehensive guide on EPRA C1 license electrical testing. This presentation will cover the mandatory regulatory inspections and procedures essential for compliance. We will begin with the regulatory framework. This section focuses on understanding the specific EPRA compliance requirements for technicians holding a C1 license. 12, 13, 14, 15. Let's discuss the essential test equipment. First, all operations must use calibrated instruments, including certified insulation testers and multifunction meters. Second, the integrity of testing leads is critical. This involves verifying test probe resistance and the condition of their insulation. Third, appropriate personal protective equipment, such as insulated gloves and mats, is mandatory. Finally, it is imperative to maintain complete documentation, including calibration certificates for all measuring tools. Now, we will address DED testing procedures. This includes continuity testing to verify protective conductors and main bonding links. We will also cover step-by-step measurement of end-to-end loop resistance for ring final circuits. Furthermore, insulation resistance testing must be conducted at 500 volts DC to ensure dielectric integrity between conductors. Lastly, a polarity check is required to confirm that all single-pole devices are correctly connected within the phase conductor. Moving on to live testing requirements, it is necessary to measure the incoming supply voltage, specifically phase to neutral and phase to earth levels. We must also calculate earth loop impedance, known as Z's values, to ensure the rapid disconnection of supply during a fault. The performance of residual current devices, or RCDs, must be verified by testing trip times at half, full, and 5 times the rated current. For all three-phase installations, a mandatory phase rotation sequence verification is also required. This section is dedicated to disconnection time standards. We will review the maximum allowable trip times for various circuit protection devices to ensure they operate within the required safety parameters. Next, we will cover the verification of earth systems. This involves the measurement of resistance to earth for TT systems through earth electrode testing. It also includes the inspection of bonding connections to gas, water, and structural steel. For TNCS supply configurations, there are specific checks required to ensure PME safety. Finally, we must cross-reference the cross-sectional area, or CSA, of earthing conductors against their current carrying capacity to verify correct sizing. A logical approach to fault finding is crucial. The process begins with a visual inspection to identify primary issues like thermal damage or loose terminations. This is followed by sectionalization, a methodical isolation of circuit branches to locate insulation faults. All findings must be interpreted by comparing measured ohmic values against the standards set in BS 7671 or relevant local regulations. 237. Finally, safe isolation procedures must be followed during the rectification and subsequent retesting phases. The final stage is certification and reporting. A schedule of test results must be completed with accurate recordings of all measured resistance and time values. Any observed defects are to be categorized using C1, C2, and C3 codes. 145. A formal declaration of compliance is then signed, confirming the installation meets EPRA safety rules. 13. Lastly, original certificates must be delivered to the owner of the installation for their records.